Bob, you head up manufacturing and production here at Autodesk. What's the component we can see here?
This is a seat frame for an aircraft seat. We used our generative design technology to be able to design this. As you can see, it's a very organic looking structure. We're trying to learn from nature about how nature designs structure, and nature does it very efficiently, and it's generated and evolved over time. And so we wanted to use that technology to look at what we could do for a seat frame that would meet the requirements but lighten the weight significantly. And so we used additive manufacturing to create a mold for investment casting for this part. And so that's it.
And what's the typical saving?
So weight savings on this would be over 50% from a standard seat frame. You can multiply that by the hundreds of seats that might be on a wide body aircraft. That can lead to significant weight savings, which then leads to significant fuel savings.
So did we use NetFabs exclusively on this product, or maybe some of your other offerings as well?
So we used generative design, which is just now being included in NetFab, and then used NetFab to do all the preparation for the additive manufacturing mold that was used to create the investment casting.
That's interesting, because you've got Fusion, you've got all these other products, but it's pretty much all done using NetFabs.
Yeah, I mean, we use some Fusion to create this outside geometry, develop the package space that you're using to run the generative design. So with generative design, you would basically define the overall structure and geometry, which would be done in Fusion. And then here we would designate all of this area as designable space and let the generative algorithm go through and determine what the optimal distribution of material is within that space. So really, generative is a technology that allows you to define a set of variables, a set of constraints, and a set of objectives, and then present to the user a wide range of solutions that meet those constraints and objectives and within the variables that you've given them. And so those could be engineering variables, they could be business variables, they could be passenger comfort variables, aesthetics, a whole wide variety of variables that we can consider.
I used to do a little bit of skateboarding in my youth, but I'm joined by a gentleman who knows just a little bit more than me. What is Project Tost?
It's about the topology optimized skateboard trucks. It's more about the technology than about skateboarding. It should show the possibilities for generative design in combination with additive manufacturing for hybrid design. And hybrid design in this case means combining topology optimization with lattice structures.
And I know Autodesk have helped you out greatly, haven't they? How have they helped?
Autodesk provided me all the software. I used Autodesk Fusion for the topology optimization with the awesome cloud solving possibilities. And I used NetFab Ultimate for the topology for the lattice structures, and also for the build preparation, support structures and everything.
We're an additive manufacturing bureau down in New Zealand. We operate RCAM EBM equipment. So we're supplying parts into the aerospace market, the medical market, high-tech marine market, motorsport, art, fashion, pretty much everything.
And I know you're proud partners of Autodesk. How have they helped your business?
They've helped us simplify a few functions in the medical area particularly. Some of the software functionality we just couldn't find anywhere else. So they've actually improved the end product. They've enabled us to put fit-for-purpose medical implants into patients.
And you do additive manufacturing at your company, but it's a little bit different to everyone else in the hall, isn't it?
Yes, it's true. So we do additive manufacturing with binder jetting, and we print small metal pieces with high details and very high accuracy. We do everything from jewelry to aerospace. We have dental application, we have medical application, we have a lot of industrial application, and there is a lot of everywhere where you need small complex components with good accuracy, which you usually need on small components.
In terms of software, how do Autodesk help you?
We will have we use several of the products, and I would say it's a good product for visualize the components, check the geometries, quality control of the file before we go to production and so on.
So the important thing is what you see on the screen is what comes out of your machine, so you know it's right, you haven't wasted money.
Well, I would say what the important thing is that the 3D geometry is what the customer wish and not something else.
Desktop Metal, I know you're proud partners of Autodesk. How have they helped you?
We like the way that Autodesk is moving forward with looking at the whole ecosystem. Everything in life, books, music, video, is all about content. And Autodesk is getting into that content game, enabling from different industry, from AEC to mechanical design, but also pushing what is 3D printable, like topology optimization. So that we like the direction where Autodesk is moving towards more 3D printability that can be 3D printed. And we like that direction because software, hardware, and materials have to come together to take 3D printing to the next level.
I think software is part of the ecosystem in 3D printing, and hardware without software is nothing. And Autodesk plays a big role also, working with our company together, or we work with Autodesk. And there's a lot of work to do on the software side in general in the industry. Because if you want to make this technology accessible to the industries and vertical markets which were never been confronted with 3D printing before, the software must becomes more accessible, easier, standardized, uniform, working on Macs, Windows, and easy to explain also to even in the educational sector.
And I know with their Fusion product, plus their other products, we're also trying to get designers to design for print rather than design for manufacturing.
Yes, so it's true that there is obviously a split before design just for the design for the manufacturing. So in this case, you indeed need to split the software and create one version for designers, another one for manufacturers.
Well, there's two areas where Autodesk has helped us. Autodesk is a powerful CAD software tool, which we do use for design of our machines in our R&D department, and we're in frequent conversation with Autodesk there. The second thing is that Autodesk also is, after acquiring NetFab, getting a plug-in for using 3D printers directly in connection with the CAD software, and that helps promoting our market, and that's why we're happily engaged with them.